one last point I want to make before we're done with SDS page gel and can move on to other things, and that's what I want to talk about is how I can estimate molecular weight. Okay? So if I plot the molecular weight, and here I'm going to plot the mobility, or RF. This is the top of the well. This is where our marker dye ended up. And our proteins moved a certain distance down here. And we're going to define the mobility, the relative mobility, or RF, is how far into the gel did our proteins move compared to the dye front that moved all the way at the front. So x over y is what we're going to call our mobility. Okay? And it turns out that the mobility is proportional to the minus the log of the molecular weight. Okay? So if I plot the molecular weight and I plot it on a logarithmic scale, note, log scale. Okay, I'm plotting it logarithmically. What I find is that for proteins of known molecular weight, I can get a straight line. And I can use this, if I want to generate a standard curve. Now, you can see that here. Okay, and so if I measure this molecular weight, what I find, again, is that the mobility is proportional to minus the log of the molecular weight. So instead of putting mobility here, I could just put molecular weight, right? And these would all be a different molecular weight. Okay, this might be 200, and this one might be 100, and this might be 75, and I'll get a beautiful straight line. So now if I don't know what the molecular weight of my protein is, I can run it on an SDS page gel, and I can simply say, oh, well, what was its mobility? Well, its mobility was right here. Okay, and then I simply walk that up to the line, walk it over, and that tells me exactly what the molecular weight was of my unknown. So if on an exam I were to give you a curve like this and tell you that your unknown protein had a certain mobility, you wouldn't have any trouble telling me what its molecular weight is, would you? Most of you, I bet, cheat. Most of you probably use the molecular weight markers on your gel and say, it ran somewhere between this marker and that marker. It's probably about 55 kilodaltons or something. But what I'm telling you is you don't have to do that. You can measure it exactly. And you can say for sure it's 53 or 54 or exactly what it is. Okay. Now, there are two other techniques that we can use to separate proteins by electrophoresis without doing SDS page. Now, by the way, why is it called page? I told you why it was called SDS. What's that page thing stand for? What's this page term mean? Polyacrylamide. Yes. Thank you. Polyacrylamide gel electrophoresis. So now you know what SDS page is. The SDS is sodium dodecyl sulfate, polyacrylamide gel electrophoresis. Very good. Okay.